Hello everyone. In the last two videos, we have solved the transformation of some standard sequences, few properties and problems based on those properties. Today I am going to explain inverse Z transformation, which is very useful to know for the purpose of designing a filter. There are so many methods to calculate inverse Z transformation. For example, long division method, direct computation method, partial fractions expansion method, power series expansion method, etc. In our syllabus, we have to solve inverse Z transformation by the method of partial fractions. So today I am going to solve few problems based on partial fractions method. Then what is inverse Z transformation? We know the definition of Z transformation. What is Z transformation? It is Z transformation of Un equals summation n equals 0 to infinity Un into Z power minus n equals U bar Z. So take this Z transformation to right side, that is Z inverse of U bar Z equals Un. So this is the definition for inverse Z transformation. That is, we are going to determine the sequence Un which generate the given Z transformation. Here Un is the inverse Z transformation of U bar Z. Before moving to the problem part, let us know few standard inverse Z transformations results. These are all some standard inverse Z transformations results. That is, we know the Z transformation of 1, that is Z divided by Z minus 1. We know the Z transformation of n, that is Z divided by Z minus 1 whole square. Here the inverse is Z inverse of Z divided by Z minus 1 is 1, Z inverse of Z divided by Z minus 1 whole square is n. Like that, we have some standard inverse Z transformations results here. Okay, first problem, find the inverse Z transformation of Z divided by Z minus 1 into Z minus 2. So, for solution, let U bar Z equals Z divided by Z minus 1 into Z minus 2. So take this Z to denominator of left side, Z equals 1 over Z minus 1 into Z minus 2 for the simplification purpose. 1 over Z minus 1 into Z minus 2 equals. So partial fraction of, we already know the partial fractions method. So 1 divided by Z minus 1 into Z minus 2 is A divided by Z minus 1 plus B divided by Z minus 2. So we need to find the constants A and B. Then by taking LCM and cancelling those two things, we can write A into Z minus 2 plus B into Z minus 1. So put Z equals 2 and Z equals 1. If we put Z equals 2, so 2 minus 2 is 0, 1 equals 2 minus 1, it is B into 2 minus 1, that is the value of B is 1. If we put Z equals 1, we will get 1 equals A into 1 minus 2 plus B into 0, that is A equals minus 1. So substitute those values to here, we will get U bar Z by Z. I can write 1 over Z minus 1, Z minus 2 as U bar Z by Z. A, it is minus 1 divided by Z minus 1 plus B, 1 divided by Z minus 2. So multiply this Z, take this Z to right side, we will get Z bar Z equal U bar Z equals minus Z divided by z minus 1 plus z divided by z minus 2. Then what is the inverse for this? So z inverse of we know the standard result of z inverse of z divided by z minus 1, it is 1 power 1. So minus plus z divided by z minus 2 is 2 power n. So I can write this as 2 power n minus 1. Second problem. Find the inverse z transform of 3z square plus 2z divided by 5z minus 1 into 5z plus 2. Let u bar z equals 3z square plus 2z divided by 5z minus 1 into 5z plus 2. If I take z common and take that z to here, we can write this as u bar z by z equals 3z plus 2 divided by 5z minus 1 into 5z plus 2. So if I apply 3z plus 2 divided by 5z minus 1 5z plus 2. If we apply partial fraction method, I can write this as a divided by 5z minus 1 plus b divided by 5z plus 2. And take LCM and cancel the denominator, we get 3z plus 2 equals a into 5z plus 2 plus b into 5z minus 1. So we need to find the constants a and b. To find a, let's make b 0, and to find b, make a 0. To make b 0, we need to replace 5z minus 1 equals 0, 5z equals 1, z equals 1 by 5. So put z equals 1 by 5, we'll get the value of a. If we put 5z plus 2 equals 0, 5z equals minus 2, z equals minus 2 by 5. If we put z equals minus 2 by 5, we'll get the value of b. So put z equals minus 2 by 5 and z equals 1 by 5. Then this becomes 3 into z minus 2 by 5 plus 2 equals a into 5 into minus 2 by 5, a into, so no need to write this, minus 2 by 5, 5 can get cancelled, minus 2 plus 2 is 0. So a into 0 will remain with b into 5 into minus 2 by 5 minus 1, 5, this 5 will get cancelled. So 5, 3 into minus 2 by 5, so it is 3 into 2 minus 6 by 5 plus 2, minus 6 by 5 plus 2 equals b into minus 3. So 5 into 2, 10, 10 minus 6, find out, it is 10 minus 6, 4 by 5 equals b into minus 3, will get the value b equals minus 4 by 15. Similarly, if we put z equals 1 by 5, then 3 into 1 by 5 plus 2 equals a into 5 into z, 5 into 1 by 5 plus 2, 2 get cancelled, so 3 by 15, so 3 by 5 plus 2, it is 3 by 5 plus 2 means 5 into 2, 10, 10 plus 3, it is 13 equals a into 3. So the value of a is 13 by 15. Apply this a and b value to here. So I can write this 3z plus 2, 5z minus 1 and 5z plus 2 as u bar z. It is u bar z by z equals u bar z by z equals, in the place of a we have 13 by 15 1 over 5z minus 1 minus 4 by 15 into 1 over 5z plus 2. So u bar z equals 13 by 15, take this z to right side, z divided by 5z minus 1. So we know some standard inverse z transformations. For that result we should have z coefficient 1. So take 5 outside, we'll get 1 by 5. Similarly here, minus 4 by 15, take this z to right side, z divided by, take 5 outside, z plus 2 by 5. So finally z inverse of u bar z equals, if I apply z inverse here, z inverse of, the final answer is 13 by 15 into 5, 75. So z divided by z minus 1 by 5, it is in the form of z divided by z minus k, k power n, that is 1 by 5 power n minus 4 by 15 into, it is minus 2 by 5 power n. This is the required result. So next problem, find z inverse of z cube minus 8z divided by z minus 4 whole cube. Let us take this as, let u bar z equals z cube minus 8z divided by z minus 4 whole cube. So before going to partial fractions method, for this particular problem we should have some assumption. If we apply partial fractions here, we'll get a divided by z minus 4 plus something b divided by z minus 4 whole square plus c divided by z minus 4 whole cube. Then what is the inverse z transformation of these results after getting the final value? So if we have whole square in the denominator, then we have two different choices for inverse z transformation. First one is z inverse of z divided by z minus 1 whole square. Z inverse of z divided by z minus 1 whole square is n. And another one is z inverse of kz divided by z minus k whole square is k power n into n. Look at the denominator here. We have z minus 4. If we have z minus 1 whole square, then the result will be n. But here we have z minus 4 whole square. So we have 4 here. Our final result will be something into 4 power n into n. That something is our constant b value. So similarly for z minus 4 whole cube, we have z inverse of z square plus z divided by z minus 1 whole cube and z inverse of kz square plus k square z divided by z minus k whole cube. The inverse z transformation for this is n square and for this is k power n into n square. The result, if we have z minus 1 whole cube here, then we can take this one directly. But here we have some value, that is 4. So in the final result, we'll get our inverse z transformation as something into k power n square. That something value is constant c value. First we need to rearrange this z cube minus 8z divided by z minus 4 whole cube. As I already mentioned, if we have z minus 4 whole cube, we'll get the partial fractions as a divided by z minus 4, b divided by z minus 4 whole square plus c divided by z minus 4 whole cube. For that purpose, to find the inverse z transformation purpose, we should make some arrangements, that is If we have z minus 4 in the denominator, then we should have z here. The inverse of this is 4 power n. Similarly, if we have z inverse of z minus 4 whole square here, then we should have kz divided by z minus k whole square. Kz means 4z. The answer is 4 power n into n. If we have z inverse of z minus 4 whole cube in the denominator, then we should have kz square plus k square z. Kz square, it is 4z square plus k square, it is 16z. The answer will be 4 power n into n square. So I can write this z cube minus 8z divided by z minus 4 whole cube as, let z cube minus 8z divided by z minus 4 whole cube. After applying partial fractions, I can write a into, take this one, z divided by z minus 4 plus b into, next one, z minus 4 whole square. For that one, take 4z z minus 4 whole square plus c into, and take this one, 4z square plus 16z divided by z minus 4 whole cube. If we remove ABC and simplify this z minus 4, take LCM for z minus 4 whole cube and simplify, we'll get the same result, that is z cube minus 8z divided by z minus 4 whole cube. So nothing will change. So next, to take LCM and cancel, we'll get z cube minus 8z equals a into z into z minus 4 whole square, because we have z minus 4, LCM is z minus 4 whole cube, plus 4bz into z minus 4, we have z minus 4 whole square here, plus 4, we can take 4z, we can take c into 4z common, that is z plus 4. So we have z minus 4 whole cube only. So we can take 4c z common. Next, if we take z common, we'll get z square minus 8. And also here also we have z. So that z and here common z will get cancelled. We'll remain with a into z minus 4 whole square plus 4z into, 4b into z minus 4 plus 4c into z plus 4. I will write this again here for the simplification purpose. A into z minus 4 whole square plus 4b into z minus 4 plus 4c into z plus 4. We need to find the constant ABC. For that, we should make, to find A, make BC 0, to find B, make A and C 0, to find C, make A and B 0. To find C, we can simply put Z equals 4. If we put Z equals 4, we'll get A and B 0. So if I put Z equals 4 square, it is 16. 16 minus 8. So 8 equals A into this 0, B into 4 minus 4, 0. We will remain with 4c into 4 plus 4, it is 8. So 8 will get cancelled. C equals 1 by 4. To find A and B, so equate the coefficient of highest term, that is z square. If we equate the coefficient of z square, we will get 1 equals, it is in the form of a minus b whole square. We can find z square here. So coefficient of z square is a. We don't have any z square. Here also we don't have any z square. So the value of a is 1. Similarly, equate the coefficient of z. We don't have any z here. So 0 equals, again z minus 4 whole square. It is z square minus a square plus b square minus 2ab. Minus 2ab. We can find minus 8. So minus 8 into a plus z coefficient is 4b plus z coefficient is 4c. So we know the value of c and a, so substitute those things. Minus 8 into a is 1 plus 4b plus 4 into the value of c, it is 1 by 4. 4 get cancelled. Minus 8 plus 1 is minus 7, take to this. So plus 7 equals 4b. Finally b value is 7 by 4. So substitute these a, b, c values to here. Let us take this as equation. Substitute those values to equation 1. So equation 1 becomes z cube minus 8z divided by z minus 4 whole cube equals a into z divided by z minus 4. What is a? It is 1 only. So we will get z divided by z minus 4 plus b, it is 7 by 4 into 4z divided by z minus 4 whole square. Next, plus c, 1 by 4 into 4z square plus 16z divided by z minus 4 whole cube. So if we take z inverse here only, we will get z inverse of here directly I am applying linearity property. Z divided by z minus 4, as we know the inverse of z divided by z minus 4, it is 4 power n plus 7 by 4 into 4 power n into n plus 1 by 4 into 4 power n into n square. We can take 4 power n common, we will get 1 plus 7 by 4 n plus 1 by 4 n square. So this is the required result for the problem z cube minus 8z divided by z minus 4 whole square. So here remember, if we have whole square or whole cube in the denominator, then we need to adjust few things to solve problems. That is, first we should have some ideas of standard results of z transformations. If we have z minus 4 whole square in the result, then we have two different choices, that is either n or k power n into n. If we have whole cube in the denominator, then the inverse z transformation will be either n square or k power n into n square. Based on those assumptions of based on those ideas, we can simplify these type of problems. So next problem. Here given u of z equals 4z square minus 2z divided by z cube minus 5z square plus 8z minus 4. Find un. As I mentioned earlier, so un is the inverse z transformation of u of z or u bar of z. So we need to find inverse z transformation here. Let u of z, or we can write u bar of z also, u bar of z equals 4z square minus 2z divided by z cube minus 5z square plus 8z minus 4. In the denominator we don't have terms like z minus 4 or z minus 4 whole square, z minus 4 whole cube like the previous one. So we need to make some simplification. We already know how to solve these things, and we by factorization method we can find the roots, or as we did what we did in the last semester, like by using calci also we can find some results. We can write this thing is 4z square minus 2z divided by this z cube minus 5z square plus 8z minus 4. If I take z common here, if we take z common, we'll get z square minus 5z plus 8, and then simplify and then factorize those things. After simplifying those things, finally we get z minus 1 into z minus 2 whole square. Z minus 1 into z minus 2 whole square. Simplify this, we'll get the same result. This is our u bar z. So see here we have z minus 2 whole square here. So I already mentioned in the previous one, if we have whole square in the denominator, then in the result we will have either n or k power n into n. We have z minus, we don't have z minus 1, here we have z minus 2, then the result will be k power n into n. For that we have z minus 1, we have divided by z minus 1 in the denominator, so we should have z here, the result is 1 power n, and we have z inverse of z minus 2 whole square here. If we have z minus 2 whole square, then the result will be k into z, that is 2 into z. This is nothing but 2 power n into n. Then u bar z equals, then u bar z equals 4z square minus 2z divided by z minus 1 z minus 2 whole square as a into z divided by z minus 1 plus b into, we have z minus 2 for this, as z divided by z minus 1, I can simply write z divided by z minus 2 plus c into, for z minus 2 whole square, we should take this 2z divided by z minus 2 whole square. So then take LCM, and LCM will be z minus 1 into z minus 2 whole square. Here also we have z minus 1 into z minus 2 whole square. This will get cancelled. We'll get 4z square minus 2z equals a z into z minus 2 whole square plus b z into z minus 2 into z minus 1 plus 2cz into z minus 1. So we can take z common, we'll get 4z minus 2 equals a into z minus 2 whole square, and here also we have z as common, that z and this common z will get cancelled, plus b into z minus 2 into z minus 1 plus 2c into z minus 1. So I'll write 4z minus 2 a into z minus 2 whole square plus b into z minus 2 into z minus 1 plus 2c into z minus 1. So to find ABC, put z equals 2, we'll get c value. If we put z equals 1, we'll get a value, and so for the next one we have to take the coefficient of, equate the coefficient of z square on both LHS and RHS, or we can, by putting z equals 0 also, we can find the remaining result. If I put z equals 2, then 4 into 2, 8 minus 2, 6 equals, so 2 minus 2 0, 2 minus 2 0 plus 2c into 2 minus 1 is 1, 2 1s are 2 3s are, so c value is 3 only. If I put z equals 1, then 4 minus 2, 2 equals 1 minus 1 0, 1 minus 1 0, so a into 1 minus 2, it is minus 1 whole square, so that is nothing but a equals 2. So equate the coefficient of z square to know the value of b. So 0 equals, we don't have any z square here, so it is z minus 2 whole square, so we'll get z square there, that is a, z into z square, so we have z square term here, that is b, and we don't have z square term in the last one, so a plus b equals 0. As you know the value of a, it is 2, so b value is simply minus 2. So substitute those values to star, we'll get u bar z equals a, it is 2 into z divided by z minus 1. Next, b value minus 2 into z divided by z minus 2 plus c, 2z plus 3 into 2z divided by z minus 2 whole square. So if we take inverse here only, we'll get z inverse of so z inverse of 2 into z divided by z inverse of z divided by z minus 1 is 1 minus 2 into it is 2 power n plus 3 into so z2z divided by z minus 2 whole square is 2 power n into n. So we can write 2 minus 2 power a power m into a power n, mathematical indices 2 power n plus 1 plus 3n into 2 power n. So this is the required result here. So next one, find the z inverse of z cube minus 20z divided by z minus 2 whole cube into z minus 4. So I will take this as u bar z, that is z cube minus 20z divided by z minus 2 whole cube into z minus 4. As we already solved in the previous problem, so I will directly go to z inverse of z divided by z minus 2, that is 2 power n, z inverse of z minus 2 whole square. If we have z minus 2 whole square in the denominator, then this will be 2 into z, then the answer will be 2 power n into n. And if we have z inverse of z minus 2 whole cube in the denominator, then the numerator will be k into z square plus k square z k. So then we'll get 4z square, sorry 2z square plus 4z, it is 2 power n into n square. And finally we have z minus 4 here, that is z inverse of z divided by z minus 4 is 4 power n. Then by applying partial fractions method, directly we can write z cube minus 20z divided by z minus 2 whole cube into z minus 4 as a into z divided by z minus 2 plus b into 2z divided by z minus 2 whole square plus c into 2z square plus 4z divided by z minus 2 whole cube plus d into z divided by z minus 4. Then take LCM and simplify, finally we get this one. So if we take z common and here also take z common and simplify, we will remain with z square minus 20 equals a into z minus 2 whole square into z minus 4 plus 2b into z minus 2 into z minus 4 plus, so take z common, we'll get 2z plus 4, so c into 2z plus 4 into z minus 4 plus d into z minus 2 whole cube. So to find the constants, put z equals 2, z equals 4, compare the coefficient of, equate the coefficient of z cube, or next we equate the coefficient of z square, or simply by putting z equals 0 also we can find the result. If we put z equals 2, we'll get c value 1, we get the d value minus 2. If we equate the coefficient of z cube, we don't have any z cube here, we get 0 equals a plus, so we have a plus d, then a equals plus 1 by 2, and if I put z equals 0, we'll get 0, the value of b, that is 0. So substitute those values to here, we'll get z cube minus 20z divided by z minus 2 whole cube into z minus 4 equals a into z divided by z minus 2, it is 1 by 2 into z divided by z minus 2 plus b into something, we have b equals 0, so leave it. Next is c, 1 into, so directly I can write 2z square plus 4z divided by z minus 2 whole cube plus d into, so we have minus 1 by 2 into z divided by z minus 4. Z inverse for this thing is, z inverse will get 1 by 2 into 2 power n plus, it is 2 power n into n square minus 1 by 2 into 4 power n. So this is our required result. Okay, I will give some simple problems to solve yourself. It is 8z square divided by 2z minus 1 into 4z minus 1, 2z square plus 3z, z plus 2 into z minus 4. We can simply solve this by using partial fractions method. So today we have learned for inverse Z transformation by using partial fractions method. In the next class we are going to solve difference equations problems by the application of Z transformations. Thank you.